Hi everyone, welcome to today's class. Today we will be doing some questions from superposition principle and we will be starting electric field. That is the next topic. I will give you a question. This was the last class question. Okay. I will give another question. Two charges plus Q and minus 3Q are placed fixed on x-axis separated by a distance d. Two charges Q and minus 3Q are fixed on x-axis separated by a distance small d. Where should a third charge 2Q third charge 2Q be placed such that it will not experience any force? It will not experience any force. Okay. So we'll draw the diagram. This is charge small q. Another charge is minus 3Q here. These are separated by a distance small d. This distance separation between them is small d. So you have to place a charge Q, third charge 2Q, such that it will not experience any force. Okay. See, anyway, suppose you place the charge 2Q here, suppose. If you place it on at this point, you know, minus 3Q attract it, this plus Q will repel it. So total force will not be zero because both the forces are in the same direction. So we cannot keep the third charge 2Q at the between Q and minus 3Q because total force on it will not be zero. Force exerted by charge at A and charge at B will be along the same direction. So this is not possible. Okay. Not possible. Now Q minus 3Q. Okay. Distance D. Now suppose we place this charge 2Q here at a distance x from small q, right? Now force on this charge, say C, due to charge minus 3q is in this direction. Okay, that is FCB. And force on 2q due to the charge at A will be in this direction. So they are equal and opposite. They are equal. Okay, they are opposite direction. So net to force can be 0. Okay, if these two forces, they are in opposite direction, right? So net to force can be 0 at this point. Now we are calculating what this distance. So what is the condition here according to superposition principle? FCA magnitude will be, say, equal to FCB. Okay, then only they are cancelling. FCA, K into force between C and A. What is C? 2Q. Charge Q divided by X square. Force between C and B. K. What is the charge? 2Q. 3Q. Take 3Q only. Don't put minus because we already considered the direction there. Divided by, what is the distance now? C to B, that is D plus X whole square. You can cut K, K, Q, Q, you cut, Q, Q, you cut. So what will be the remaining? Rearranging, you will get D plus X square divided by X square is equal to, this 2 you can cancel, this 2 you can cancel, you are getting 3. Okay. Now, if you cross multiply, D plus X the whole square will be 3X square. Now you can expand this. Open the bracket. A square plus B square the whole square, A square plus B square plus 2AB. That formula you use, A plus B the whole square. So here it is X square plus D square plus 2dx is equal to 3x square. Now you can take x square to all terms to the other side. So 3x square minus x square, 2x square minus 2dx minus d square equals 0. So you can find out x. It is a quadratic equation. So what is the root? X is equal to, you know the equation, minus b plus or minus root of b square minus a square. What is the equation? Minus b plus or minus root of b square minus 4ac by 2a. So we put the value there. Here what is x is equal to minus, b is minus 2d here. So we can write 2d plus or minus root of b square, 2d square. So 4d square minus 4 into a. A is 2 only, right? C is minus d square. So it becomes plus, so d square by 2 into a. 2, a is here 2 only, right? So x is equal to 2d plus or minus root of, this is 4d square plus 8d square. So 12d square whole divided by 4. This will be 2d plus or minus, this is 12 is 4 into 3, 12. So 2 root 3 d by 4. So x equals, you can cancel by 4, d by 2 plus or minus root 3 d by 2. So x has two roots. You take positive value only. If you take negative value, it means that the point is between q and 4, between q and minus 3q. Q and minus 3q, we already ruled out the possibility. Listen, if you take minus root, the point will be between q and minus 3q. That is not possible. We ruled out it first. Okay. So what will be the answer? X will be, you can take common. What common you can take? D by 2 into 1 plus root 3. This to the left of q. Okay. One more example. Three-point charges are placed at the 3-point charges Q. Charge is given. 3-point charges Q. Q each are placed at the vertices of an equilateral triangle of side L. Find the sine and magnitude of the charge that must be placed at the centroid of the triangle such that the charge on any of its vertices is in equilibrium. Okay, this is the question. So similar one we have done. Okay. So first you draw the diagram. See, this is an equilateral triangle. Okay. Its side is L given. Name the vertices A, B, and C. Now, charges placed Q, all charges Q only on the 3 vertex. Now you are placing a charge at the centroid. You know what is centroid? You have to draw medians from each vertex to the opposite side. And these medians will meet at the point, that point is called a centroid. So this point is the centroid. You take this point as O, name this point as O. Okay. You need to place a charge Q such that this charge you take as Q dash. You need to place a charge Q dash such that charge on all the vertices is equal, charge equal. Any of the vertices is in equilibrium. So we consider the charge B. For the charge B to be in equilibrium, we know the net force on charge B should be 0. Okay. At B to be in equilibrium, the net force on it must be 0. Now we are calculating the net force. So, you know, this charge at A repel the charge at B. So this force is in this direction. And writing as FBA, charge on B due to the charge at A. Similarly, the charge at C repel B in this direction. This I am writing as FBC. Now, resultant of these two will be in this direction. This I am writing as, say, F. So what is this F? F is the resultant of FBC and FBA. Now listen, I can find out this. You see FBC is the force between B and C. And FBA is the force between A and B. These forces are equal because charges are same magnitude, length, distance between also same. So we can write this F as root of F BC square plus F BA square plus 2F BA F BC cos equilateral triangle. So what is the angle? 60 degree. Cos 60. So FBC, FBA are equal. So we can write root of FBC square plus FBC square plus 2FBC square cos 60 1 by 2. On simplifying, you will get root 3FBC. Okay. So this is the net resultant force. No, not the total force between BC and FBA. Okay. This is the force between BC and BA. Charges at Q and A and C. Now listen. Now at the centroid there is a charge Q dash. So that should be opposite direction. That I am writing as F dash, right? So F is upward. F dash Q force exerted by Q dash on AB, that has to be downward. Then only total force can be 0. They must be in equal, right? So what is the net to force on the charge at B? Net force on the charge at B. This F is the resultant between FBC and FBA plus F dash. What is F dash? The force between charge at the centroid and charge at the vertex B. That has to be 0. Okay. And now you can put the values. You know, F is the force between this one. You know, F is root 3 FBC. plus what is this F dash? Force between Q dash and Q at the vertex B. You can write K Q dash Q by distance from center to the vertex that we are taking as BO square should be 0. Okay. Then I'm writing root 3 into what is force between B and C? K Q square by AB square plus K Q dash Q by BO square equals 0. Now AB side of the triangle is given as L. You have to find out that BO. AB is L only. To find out BO, BO is the distance from each vertex to the centroid. AB is L. Now, from the triangle, you see the triangle, this angle. What is this angle? Angle A is 30. This what I marked the angle. Now I mark that angle is 30 degree. You know, AO you can find out. Here AO and BO are same. AO, BO, CO all are same. Centroid distance from the coordinates. So AO equals BO. I'm finding it. Okay. So from this triangle, you take this midpoint as say M. From the triangle AMO, you can consider the triangle AMO. AMO. What is cos theta? Cos 30 is adjacent side AM. AM is half the side, right? Half the side. So L by 2 divided by AO. We can write BO also, BO, right? So what is BO? BO equals L by 2 cos 30. L by 2 cos 30 is root 3 by 2. So 2 cancel, you get L by root 3. Okay. So that is the value of BO. That's the value of BO. So we can put this in this equation. Therefore, what you are getting, you can cut the K from all this equation. One charge also you can cut, small q. So what is the remaining? Root 3 q divided by AB is L. L square plus q dash divided by BO. What is BO? L by root 3 the whole square equals 0. So root 3 q by L square plus q dash into L by root 3 square is 3. 3 go to the numerator by L square equals 0. You can cut L square also. What you will get? Root 3 q plus q dash into 3 equals 0. Then you can find out that q dash. 3 q dash is equal to minus root 3 q. So q dash equals minus root 3 q by 3 is equal to minus q by root 3. So this is the value of the charge. Okay, children? This is an important question. This is a board question. Okay. Previous year question. Now, so far we learned till superposition principle. Now we are going to the next topic, electric field. Electric field. Field, you know, space, right? Region, right? So when you consider a charge, this charge can exert force on other charges. So when some other charges come near to it, those charges can experience force due to it. This region around a charge where other charges can experience force due to is called its electric field. Okay, this charge we say source charge. See, to experience force, we need to bring other charges. That charge is known as test charge. Okay, test charge has to be a small charge. So what is electric field? It is a region around a charge where electric force due to it can be felt. Okay, that field, normally the field extends to infinity. Field of the charge and extends to infinity. That depends only on the magnitude of the charge. But larger charge will have larger field. Normally we take electric field is 0 at infinity. So what is electric field? It is a region around a charge where force due to it can be felt. Now we have to define it. Now, how you define the electric field? See, consider a point charge, Q. I am going to define electric field intensity. We simply call it as electric field. Imagine a point near it. So, the force experienced by placing unit positive charge at this point is known as electric field at that point. So how will you define? The force experienced the electric field at a point in an electric field intensity at a point in an electric field is defined as the force experienced by placing a unit to positive charge. You have to place 1 coulomb charge here and find the force between them. That is known as electric field at that point. So this is a definition. Electric field intensity at a point is defined as the force experienced by placing a unit to positive charge at that point. Electric field intensity. at a point is defined as the force experienced by placing a unit positive charge at that point. Okay. So electric field is defined as the force per unit positive charge. Okay. See, this is the electric charge Q. P is a point. To find the field here, suppose I am placing a test charge delta Q there. Test charge. From the name itself, it is used for testing, right? So I am placing a test charge here. Then what will be the electric field intensity here? It is the force per unit positive charge. So electric field intensity will be this one, force divided by delta Q or dQ. But there is a condition. This test charge must be close to zero. So I am writing it as limit delta Q tends to zero. That means it is a condition given. Force by delta Q. Okay. So what is the equation for electric field? Limit delta Q tends to zero, F by delta Q. Here Q is called a source charge. Delta Q is called a test charge. Q is the, we are finding field of Q, that is on a source charge. Delta Q, test charge. Okay. So electric field at a point is defined as the force experienced by placing a unit charge at that point. To find the electric field, we use a test charge, small test charge. Delta Q tends to be zero. Why? What is the reason? Why the test charge has to be small? Suppose this test charge is large, then you know the test charge has a field, large field that may interact with the source field. So we won't get the exact field at that point. That's the reason. So why the test charge must be vanishingly small? What is the reason? If the test charge is large, it will have its own field, right? That will interact with the source field. So we will not get the exact electric field at the point P due to the source charge. We will get a resultant field, right? So it can be asked for as a short answer. By determining the electric field, why the test charge must be vanishingly small? What is the reason for it? If the test charge is large, it will have its own field that will interact with the source field. That's the reason. Okay. The test charge must be vanishingly small, tends to zero. What is the reason? Otherwise, the test charge will have its own fields that may interact with the source field. So we will not get the exact field due to the source charge. We will get a combined field. Okay. Now, what is the SI unit? You know, force by charge. Force Newton, charge Coulomb. So SI unit of electric field. Electric field intensity. Actually, electric field intensity we usually call as electric field. It is represented by the letter E. SI unit of electric field is force by charge. Force is Newton. Newton charge is Coulomb unit. So Newton per Coulomb. So SI unit of electric field is Newton per Coulomb. One more thing you have to remember, this electric field is a vector quantity. It is force by charge. Force is a vector. Charge is a scalar. So electric field is a vector only. Okay. And it has direction. And what is the direction? For a positive charge, electric field is directed radially away from it. For a negative charge, electric field is directed radially towards it. It is important. You have to remember. For a positive charge, electric field is directed radially outwards. So electric field is pointing away from positive charge. So this is a positive charge. Electric field direction is like this. For a negative charge, electric field will be pointing towards it. For negative charge, electric field is directed radially inward towards the charge. Towards the charge. Negative charge, electric field is like this, towards it. So we learned what is electric field. For a common man, what is the meaning of electric field? It is a region around a charge where electrostatic force is experienced. How will you define it? Electric field at a point in an electric field at a point. Electric field intensity. We define electric field intensity. How it is defined? Electric field intensity at a point is the force experienced by placing unit positive charge at that point. Equation for electric field intensity E is F by Q. Equation is limit delta Q tends to 0 F by delta Q. What is the significance of delta Q tends to 0? The test charge must be vanishingly small. Otherwise, what will happen? Otherwise, the test charge will have its own field that will interact with the source field. Okay. Electric field is a scalar vector quantity. What is the direction? For a positive charge, it is radially acting outward. Negative charge, it is radially acting inward. Okay, students. Today, now we will stop the class. We will continue in the next class. Okay. Always watch the video, learn it regularly. practice. Bye bye for now.